What is network traffic analyzer? Network traffic analysis involves monitoring, capturing, and analyzing data, packet transmitted over a network to detect anomalies, improve performance, and ensure security. Why is it so important to have network traffic analyzer? With the increasing frequency and sophistication of cyber attacks, such as DDoS attacks and port scanning, effective network monitoring is crucial to safeguarding sensitive data and maintaining operational integrity. For problem statement, we identify three main problems, which is identify gaps, current challenge in network traffic analysis, and the need. For identify gaps, there are lack of dynamic and static feature integration for threat detection, and we also need for scalable Python-based solution for packet tracer analysis, for PCAP analysis. And for current challenge, the current challenges that we find out in network traffic analysis is tools are resource intensive and lack user-friendly interfaces. It is also limited capability to detect evolving cyber threats, and it's also insufficient real-time analysis in existing tools. And the need for network traffic analysis is we need a lightweight, efficient, and accessible tool for detecting anomalies and malicious activities in network traffic. The main goal for our project is to develop a Python-based network traffic analyzer for effective forensic analysis. There are three specified objectives that we need to achieve, which is to design a tool which analyzes packet capture files to identify anomalies and both DDoS attacks and port scans. Second, to implement data processing and visualization tasks through Python library, which is PyShark. And third one is to develop a friendly graphical user interface, which is GUI, which ensures easy to navigation for user interaction. For our project scope, there are three focus areas, which is analysis of packet capture files for network anomalies. Second, detection of malicious activities such as DDoS attacks and port scanning. And the third one is extraction of key metrics, which is IP address, ports, protocols, and data flow patterns. The output that we want for our project is the actionable insight present through visual reports and charts. Second, anomaly detection result for forensic investigation. And the limitation for our project is it does not include advanced cryptographic analysis, and the real-time packet sniffing is beyond local PCAP files is out of scope. For our project significant, there are four significant for our project. The first one is enhancing network security. For enhancing network security, our project needs to address the growing need for effective tools to detect and analyze cyber threats. For second one, which is bridging accessibility gaps. We want to provide a user-friendly and scalable solution suitable for both professionals and students. And the third one is practical contribution. We want to support forensic investigators with actionable insights and visualize data for anomaly detection. And last but not least, foundation for future development. Our project is a modular design allows for easy integration of advanced features like machine learning and real-time monitoring.
Next, we analyze some existing tools such as PyShark and Snot. Snot is excellent for protocol analysis, but it struggles with encrypted data and lacks of automated anomaly detection. On the other hand, Snot also provide the real-time monitoring, but requires manual configuration and making it less user-friendly. A combination of dynamic traffic patterns, data IP, and protocol type features can improve the anomaly detection. However, while deep learning models enhance accuracy, they come with high processing demands. Finally, they identify key gaps in project motivation. The current analyzer face challenges with real-time performance, scalability, and encrypted traffic analysis. Our proposed solution is a Python-based analyzer aims to address this issue using lightweight libraries, real-time performance automation, and enhanced visualization for forensic investigation. Next, let's look at the related works where we compare existing tools with our proposed Python-based network analyzer. Starting with input, existing tools like Wireshark capture live network traffic or read packet capture files from such as PCAP. Similarly to our Python-based analyzer, can process network traffic in real time or from PCAP files using Python libraries. For output, existing tools provide detailed tables, graph, and protocol dissection, where our analyzer focus on protocol distribution, traffic pattern over times, identifying top talkers by source IPs, and packet size distribution. In terms of UI design, existing tools mainly rely on GUI interfaces like Wireshark or command line utilities like TCP/DOM, where our system features has a coded GUI with a simplistic design. Regarding the complexity, existing tools are user-friendly and require minimal technical knowledge. However, our Python-based network analyzer more flexible, demands moderate to high Python coding skills and understanding of libraries. Lastly, in terms of functionality, existing tools offer comprehensive support for a wide range of protocols and filters. Our solution visualizes data and with plotted graph for protocol distribution, traffic over times, talkers, packet size distribution, and detecting potential DDoS or DOS attacks.
Now, for the system design, as you can see at the logical diagram, the user will have to select the picket file first, and then the program will then analyze the picket file, and the output will be plotted graph and the suspected IP addresses. So the input will be picket file, the process will be program analyzing the traffic, and lastly the output will be plotted graph and list of suspected IP addresses. Now for the workflow, for the first step, the user have to execute the program code. Then for the second step, user will have to upload the desired picket file. Then the user will have to wait for a while. And lastly, the output will be generated on the GUI. Next, this is the proposed flowcharts for the network traffic analyzer that we created. And this is the list of Python libraries that we use. Starting with the first one, TicketInter for providing tools for generating GUI. The second one is TicketInter.file dialog to allow user to select file. The third one is TicketInter.ttk to enhance GUI appearance. The fourth one is TicketInter.messagebox to display pop-up messages. The fifth one is matplotlibary.pyplot is to plot graph. The sixth one is matplotlibary backend underscore tkagg to display results. The 7 libraries is pandas to analyze pcap in data frames. The 8 libraries is seaborn library to enhance output asterisks. The 9 library is the collections.counter to count occurrences. And the lastly, PyShark, a library to read and analyze pcap file. Now, let me demonstrate to you on how to use our tool. As you can see, this is the program code for the created tools. So first of all, the user will have to execute the program code first. It will take a while for the program code to start. And now this is the GUI created, Network Traffic Analyzer DDoS detection. This program will analyze picket file for traffic patterns and potential anomalies with just one click. Then the user will have to click the load and analyze picket file and select the desired picket file. So for this one, I will choose the picket file, and as you can see, the prompt message will go out. And the second prompt message will also pop out. Now the user will have to wait for a while the program code is analyzing the picket file. So this is the result created, which is the protocol distribution graph, traffic over time graph, top talker source IPs graph, packet size distribution graph, detected anomalies list, as you can see. And lastly, the summary of suspected source IPs. Now for the result, the first result will be the protocol distribution graph. For the second one is traffic over time graph. For the third result is top talker source IPs graph. The fourth result will be packet size distribution graph. The fifth result will be detected anomalies list. And lastly, for the last result that will be generated by the system is the suspected IP addresses. Going to the analysis phase, we have to find out what is the purposes of each graph. So for the first graph, the protocol distribution graph, the purpose is to illustrate the count of packets categorized by different protocols. Next, for the traffic over time graph, it is to provide a time-based trend of network activity for spotting irregular traffic patterns. For the third graph, which is the top talker graph, The purpose of the graph is to identify the top 10 IP addresses generating the highest packet volume. And lastly, the packet size distribution will help to display how packet size vary across the traffic for spotting unusual packet sizes. So now, what we can do with the given output by the network traffic analyzer that we created? After receiving the plotted graph and the list of anomalies and suspected IP addresses, what we can do is to detect the root of network anomalies. Second is to identify potential threat at early stages. Third, to ensure constant efficiency state of a network. And lastly, help to monitor network performance. For the challenges, we have three major challenges in doing this project. First of all is to handling larger packet file. Bigger file size will require longer processing time, hence extra waiting duration. Next, the data visualization aesthetic. Creating a visually appealing graph is very hard to maintain the information inside the graph and also to give a very proper and appealing aesthetic of the graph. And lastly, unresponsive GUI. The GUI will occasionally become unresponsive while rendering multiple graphs. Now, what are the solutions for the challenges? So, first of all, to adjust the program code with incremental packet processing, allowing efficient file handling with lesser memory needed. Second is to implement Seaborn library to create a polished graphs with consistent styles for all the graph. And lastly, for the third solution is to use threading to separate the analysis task from the GUI interface.
For conclusion, I want to conclude our discussion by highlighting the key takeaways from this project. This Python-based network traffic analyzer enhances digital forensic by utilizing PyShark for efficient and scalable packet file analysis. Designed for both experts and students, the system strikes a balance between advanced features and ease of use. Its modular structure ensures adaptability, keeping up with evolving cybersecurity needs. Ultimately, this project strengthens network security analysis by providing a reliable, accessible, and efficient forensic tool. For the future improvement, the first point is to implementing real-time traffic monitoring. The second one is to enhancing detection algorithm for better threat identification. The third one, advancing cryptography analysis capabilities. And the fourth one, expanding the to multi-platform deployment for greater accessibility.